Welcome to the webinar on automated XY testing with Bluehill Universal. Thank you so much for being here. I'm Nick Erickson, your host for this webinar. Today, I'm joined by Theresa Smith, one of Instron's product managers within our low force applications team. She's here to discuss the automated XY testing system, review a few common applications, and discuss the all-new integration that allows for all of the XY programming to be done within Bluehill Universal software. We're also joined by a couple of our application experts, Charlie Pryor and Kyle Stone, who are here to keep an eye on questions while Theresa is presenting. These two are very knowledgeable about Instron testing systems and a wide variety of testing applications and would love to field some of your questions at the end. So I'd like to encourage you to send in any relevant questions that come to mind as we go along. So with that said, I'm going to turn things over to Theresa now.
Hello, everyone. I'm Theresa Smith, Product Manager in the Low Force Applications Group. Thank you for joining me for today's webinar on testing with an automated XY system. Today, we'll begin with a brief look at an XY system. Then we'll review some common testing applications that can be made easier when incorporating an XY stage. We'll also discuss the benefits that an automated XY system will introduce into a lab. And finally, I'll provide an introduction to the recently released features in Bluehill Universal. These features provide full stage control and testing capabilities for an XY system. The XY stage is really quite simple. It mounts to the base of a testing system using standard mounting holes. A control box is also supplied that can be secured to the column of the frame. The test surface has a bolt pattern to which you can secure test fixtures to hold the specimens or components to be tested, such as the plate shown here in gray. As you'll see throughout this presentation, fixturing is key to successful testing with an XY system. We offer standard stage sizes of 100 by 150 millimeter travel, 150 by 150 millimeter travel, and 300 by 150 millimeter travel. The XY stage is available for use on both single column and extra wide table model testing systems. They can be supplied with a new system or added to a lab's existing system. The system has a great deal of flexibility and can be used for numerous applications. In a moment, we will discuss applications that can be run on an XY system. As we do, please keep in mind the tests that you run in your lab. Many tension, compression, and bend tests that you run on a manual system can be set up on an XY system, as long as the proper fixturing is used. The addition of an XY stage to a test system brings several benefits to the lab. Increased throughput reduces the overall test time. Testing backlogs can be worked through more quickly, providing faster turnaround on data that is needed for R&D projects and on production lines. The XY offers greater efficiency, as once the operator sets up the sample and starts the test, they are free to walk away from the system to work on other value-added tasks, such as completing test reports. The stage is able to position the test component or specimens with greater repeatability. The operator influence on test results when specimens are inserted and aligned manually can be especially noticeable when you have multiple operators with varying levels of experience running tests on multiple systems. Perhaps your testing is even spread out over multiple labs. The reduced need for operator interaction when using an XY system also results in increased safety, as the operator's hands are rarely in the test space. It also offers better ergonomics, as it removes the repetitive motion that is required when manually loading specimens. To begin our discussion on applications, I'm going to play a video that shows a number of different tests being completed with an XY stage. Seeing the system in operation should give context to the rest of my presentation today. Again, keep in mind your application as we watch the video. I'm going to begin with some videos to show you some XY stage applications. XY stages are commonly used to test electronics, such as screens and keyboards. A compressive load is being applied at 9 points around the screen to simulate loads it may experience in use. Keyboard keys and trackpads are tested to measure tactility. This helps suppliers achieve the feel that consumers want in their products. After each test is complete, the stage automatically moves to the next key. In this video, we see a mini USB keyboard under test. A small keyless chuck is used to hold the test probe. The particular keys that are being tested, such as the space key, are set up in the software. After the test is complete, the stage moves into a position to make removal of the tested component and setup of the next easier. The system seen here is performing a cap removal force test on syringes. The XY stage moves the specimen to be tested into position under the crosshead. The crosshead moves down and the pneumatic grip closes onto the cap before performing the test. After the test, the cap is dropped into a collection box on the side of the stage. Compression and flexure tests are straightforward from a fixturing standpoint. But as you see here, tensile testing on an XY stage is also possible using pneumatic grips. The assembly of integrated circuits and other components on PCBs introduce mechanical stress. Here we are looking at an integrated circuit being tested in a diamond pattern. The chip is loaded in the center and then at 4 points around its edge. A compressive load of 120 newtons is applied to measure component stiffness. The corresponding voltage can be measured to qualify the materials used in the manufacturing of electronic packages. What you may have taken away from the videos is that fixturing plays a key role when using an XY system. As we look at the upcoming applications, many of the photos show manually run tests, but it's possible to run all of these and then some with an XY system. It all comes down to having the right fixturing to support multiple specimens or a component with multiple test points. There are a number of standards that provide test requirements for needles and syringes, including pre-filled syringes. An XY system can easily be adapted to run many of these tests, such as a liquid leakage test that is performed on vials, such as those seen in the photo, and on syringe closure systems, which might be a needle shield or tip cap. The test determines whether the closure system or plug can withstand possible excessive pressure inside the device during filling or shipping. Syringe breakaway force is the measurement of the initial peak force required to depress the plunger. The glide force is the average force required to continue moving the piston. This evaluates the quality and consistency of the silicone lubrication within the empty barrel. All that is needed to run these tests on an XY system is a fixture to hold multiple specimens and a probe or compression platen. From these photos, it's easy to see how a glide or breakaway force test can be adapted to an XY system using a fixture that is similar to that used for the liquid leakage test. The needle pull-out force tests the fixation of the needle to the syringe to determine whether the bonding process is appropriate. The lower lock adapter collar pull-off force test is used to check that the collar will not detach from the syringe during use. Cap removal testing is done to ensure the cap will remain in place during transport, but that a user will easily be able to remove it before use. These are all tensile tests that on a standard testing system could be run using manual or pneumatic grips. To perform these tests on an XY stage, pneumatic grips are required, as we saw earlier in the cap removal video. This is the pneumatic 3-jaw grip that is ideal for these cylindrical specimens. Surgical tools and components are often tested by simulating the forces that are applied while in use. These may require pneumatic grips for tension tests, or a simple probe, such as that used to perform compression testing on the springs shown here. Crush testing of pharmaceutical pills and tablets are performed to quantify their compressive properties, ensuring they can be packaged and handled without degrading or being crushed. Pharmaceutical bottle seals undergo puncture testing. The seal needs to be strong enough to protect the drug during storage and transport, but the customer needs to be able to easily remove it to access the contents within. Monitoring devices and medical analyzers have buttons and screens that require testing. The XY can also be used to test dental and orthodontic adhesives. The electronic devices we all use on a daily basis undergo a great deal of testing to ensure they are durable enough to withstand everyday misuse and to characterize the tactility of buttons and switches. A stiff button would require a higher force to operate it, possibly making it difficult for the user. But a sensitive button can prove to be just as difficult, as significantly small forces might cause unnecessary engagement of the device. Buttons, switches, and screens on phones, laptops, monitors, keyboards, wearable sensors, touch and trackpads, and mice, as well as remote controls, are all tested to help engineers design products that meet customer preferences. Button testing on electronic devices has become a very popular application. So Instron incorporated a series of button calculations into the Bluehill Universal calculation library. This helps make testing and data analysis for these applications quicker. These include touch force and displacement, operating force and displacement, return force and displacement, and click ratio, among others. We watched a video of this application earlier. This is a multi-point compression test that is performed on integrated circuits and other electronic packages, such as ball grid arrays and chip scale packages. A compressive load is applied to measure deflection and stiffness. The corresponding voltage at that load is measured as well. That stiffness and voltage data is used to compare various chips and to qualify new materials and forms. This fixture design is an example of how a good fixture can contribute to improve throughput and repeatability. Rather than supporting identical specimens, this fixture holds 5 structures of different sizes that are each subjected to compression at 5 points for a total of 25 tests. The use of this fixture with the XY stage ensures the test points on each chip will be consistent from one sample to the next. Performing these tests on a standard manual system would require a different fixture for each chip. The chip would also need to be manually relocated for each of the 5 test points. Ensuring the chips are all tested at consistent locations with a manual setup would require great attention and time. This slows the testing process and increases the variability in the test data. There are a number of automotive products that lend themselves well to XY testing, such as key fob buttons, the buttons on a stereo, the touch screens of our navigation systems, and climate control systems. The battery test shown here uses a manual XY translation stage to move the component between test locations. Using an automated stage, instead would offer all the benefits we've been discussing. Valves, consumer products such as razors and toys, and even materials can be tested on an XY system. Tension, compression, or bend testing on small specimens to perform QC testing or to characterize new materials being developed is possible with the system. We've looked at a number of applications, but basically any product that can be attached to an XY stage with the right fixture can be tested. I'd like to encourage anyone who has questions about whether an XY system is suitable for their particular application to either send a question in through the chat or reach out to me or their local sales engineer at a later time to discuss. Early in the presentation, we touched on the main benefits of the automated XY system: throughput, efficiency, repeatability, and safety. Let's look at each one of these in a bit more detail. We'll begin with throughput. The time of an actual test itself will be the same, whether you run it manually or use an automated XY system. It's the time taken to remove each specimen after the test and to set up a new specimen, making sure it is properly positioned and aligned, that significantly increases the overall test time. These are the areas where an automated system can greatly contribute to lab throughput. To give you an idea of how much an XY system can increase throughput, I performed some benchmark testing on springs from a surgical tool. I ran 50 tests manually, which took nearly 16 minutes. This was with no breaks or distractions, running one test immediately after another. Using the XY system, testing of the 50 specimens took about 8.5 minutes. The XY system allowed me to test 46% more specimens in a given time period. This extra time may make the difference when it comes to time to market, hitting engineering project milestones, or releasing a product for shipment. Keep in mind, this is when compared to manually testing where there are no interruptions or distractions. In reality, an operator who is manually running tests has interruptions every day, such as meetings, breaks, or even an impromptu conversation with a colleague. During those times, no testing takes place. So this 46% estimate is actually rather conservative. To maximize throughput with an XY system, many customers will have multiple test fixtures, so that while one sample is undergoing test, the operator can prepare the next sample. This minimizes downtime between tests, as the operator can quickly set up a new sample on the XY system and press start. At the same time the XY system is increasing throughput in the lab, it's also freeing up a good deal of the operator's time, as the operator no longer has to be standing in front of the system while tests are run. They're free to walk away from the system and perform other test tasks, such as data analysis, completing test reports, or measuring and preparing the next batch of specimens for testing. Using the benchmark data discussed in the throughput slide, in addition to increasing the lab throughput by 46% over the course of an 8-hour shift, the operator will gain 3.5 hours of time back that would otherwise be spent in front of the system manually running those tests. There are many factors that impact repeatability. Specimen placement is important. If the specimen is not centered properly or is at an angle compared with the loading line, this will introduce variation into the results. While there are tools available to help with proper specimen alignment, this still relies on operator experience, and time and care must be taken when setting up a specimen. This is compounded when testing multiple points on a component. The integrated chips shown in the photo here are small, ensuring that these parts are tested in the center and at the same 4 points around the edge is challenging when setting the specimens up manually. The XY stage provides repeatable test locations from sample to sample, ensuring that the data being generated is comparable. By addressing the challenges around specimen placement, an XY system with proper fixturing reduces the influence of the operator experience and specimen alignment. OSHA estimates that companies pay $1 billion in direct worker compensation per week. This doesn't include other costs related to disruptions in the lab, such as reduced staff that will likely result in lower throughput, or lost expertise if the operator injured is the only one with knowledge on how to run a particular system or test. And of course, any accident in the lab can cause operators to have less confidence when using equipment. The automated XY system reduces the need for operators to have their hands in the test space, thus reducing the risk for injury. It also offers better ergonomics, as it removes the repetitive motion that is required when manually loading specimens. Because the XY system removes some of the testing challenges around specimen alignment and test points, operators with less experience can be trained more quickly. They'll find the system easier to use and will be more confident running the tests. This lessens disruption in the lab. Instron recently introduced full XY stage and test control within Bluehill Universal. This screenshot shows you what you will see while running the test. Live displays at the top of the screen show the user the stage's current position. The graphs update with a curve for each test as it is completed. Here we are looking at force versus compressive displacement of the keys on this mini USB keyboard. The results table at the bottom contains specimen information and calculated results. This test uses Bluehill Universal's standard button calculations for click ratio, operating force, and return force. You'll note the first column in the table contains the XY test location. Each test location can be given a specific name to help better identify each test area or part. So rather than have the results displayed only by the order in which they were tested, which you can see alongside the table in gray, they can be given meaningful labels. For this keyboard test, the names of the keys being tested are used. The XY test location can also be used to group results. By doing so, the user can now see all the results from one particular key, for example, the space key. The XY stage is moved using this Bluehill Universal screen. The arrows are used to move the stage in any direction, or the user can enter in specific X and Y coordinates and press move to position to go to that location. The user is also able to zero the stage at any physical point. The move to zero button will move the stage quickly to that zero location. There are 3 XY sequences available in the software. The first is a grid. This is useful for multiple specimens that are arranged in set intervals from each other. For example, this rack with vials for liquid leakage testing is an example of a grid sequence. A preview screen provides a visual representation of the test pattern. As a user changes the number of rows and columns in the grid, and also the delta between the X and Y points, that preview screen will update to reflect the latest changes. The diamond sequence is commonly used in electronic applications where a button is being tested in the center and at 4 equidistant points around its perimeter. A custom sequence is also available, as many applications have test points that don't fit into a diamond or grid pattern, for example, a keyboard. A custom sequence allows the user to create test locations that fit a particular component. As you can see here, you're also able to name the test locations. So I use the name of the keys, such as caps lock, shift, and control. Multiple sequences can be created and stored within a test method, and sequences can be named for clarity. It's also possible to export the sequence that's created in Bluehill Universal, or to import a sequence that has been created using another program. Up to this point, all the XY testing you've seen in the software assumes that each specimen or test location on a component is being tested in the same way. Same test speed, same test end criteria, and same data acquisition rate. But that isn't always a realistic representation of how a product is used in real life. For those test scenarios, Bluehill Universal's test profiler offers more flexibility. The user can set up steps to move between various points of an XY sequence. Here, the stage is moved to the space bar in a full-size keyboard sequence. At each test location, the user can set up a ramp or cyclic waveform with the speed and step completion criteria for that particular part. We've covered many of the software details at a very high level. If you're interested in a more in-depth look at these features, we will soon have some video clips available on our YouTube channel. We'll follow up and send you an email to notify you when those videos are available. The XY systems that we've been looking at so far have also all been for use on our universal testing systems for static tests. But Instron also offers automated XY capability for fatigue and durability testing. An XY stage can be used in conjunction with our ElectroPulse electrodynamic fatigue testing system. This system allows tests to be run at high frequencies or high speeds. It can allow high number of cycles into the millions, and it provides durability and life cycle testing capability. That concludes today's presentation. Thank you for joining me for talking about automated XY systems. Charlie, Kyle, and I are ready to answer your questions. We'll begin with the questions that were submitted by today's attendees when they registered for the webinar. As we cover those, please go ahead and submit any additional questions you may have, and we'll respond to those as time allows. Thank you.
Hi everyone, this is Charlie Pryor, Applications Engineer at Instron. I've compiled a few questions that came in already that I think will have the most relevance to the audience here today. First question we have here is, how are fixtures connected to the XY stage, and can a normal grip connection type be added as well? So fixtures are connected by bolting them onto the XY stage based on the 4 M5 threaded holes on top. Instron has made custom fixtures for customers in the past, but sometimes customers also will like to design their own. Either one works. Another option, so if you want to use a normal grip connection type, to use either tensile grips or compression platens on top of the XY stage, we do offer an optional type O connection type, and it will allow for you to do testing without having to remove the XY stage. However, I would like to note that this testing is limited to 2 kilonewtons for both compression and tension, while the XY stage is still fixed to the frame. So second question is, what are the speed capabilities of the XY stage? So the XY stage is set to move at 2 different speeds depending on the action occurring. First speed is while manually jogging the stage during test or method setup. At this stage, the XY stage will move at 10 millimeters per second. Then it'll move at its maximum speed of 25 millimeters per second during testing, and that's meant to help reduce overall test time. I'd also like to note that crosshead speed of the frame is not limited when you have an XY stage connected, so the crosshead will maintain standard operating speeds there. Next question that we have. Can different steps within an XY stage method use different data capture rates? Yes. So when using our test profiler option in Bluehill Universal for setting up an XY stage method, you can choose to either use the method's standard data capture scheme, or you can override this data capture scheme for each step within the test profiler method. From there, you'll be able to select your normal data measurement or intervals as you would normally in test profiler. Next question we have, is it usable with Bluehill 3? So all new XY systems will operate using Bluehill Universal. Previously, TestMaster was used with Bluehill 3 to provide control of the XY stage movement. However, in the new XY stage systems, the stage control is integrated into Bluehill Universal. So if you're looking to add an XY stage to an existing system running Bluehill 3, you will need to update to Bluehill Universal. But additionally, if you already have an XY stage that's using TestMaster in Bluehill 3, and you want to update your software to Bluehill Universal, we can update the control module on your XY stage so that it will now be compatible with Bluehill Universal. Let's see. So the last question I have here is it compatible with existing 5900 and 5500 systems? So the XY stage is compatible with all existing 5900 single column frames as well as extra wide dual column frames. It is not compatible with 5500 frame controllers. However, if you have a 5900 retrofit on your 5500 frame, then it will be compatible with that. All right, well, looks like we have a few other questions that we'll take offline and address individually. So now I'm going to pass this over to Nick to wrap everything up.
Yeah, thanks, Charlie. So yeah, I don't know if yeah, I'm seeing like one more question come in. I don't know if that you want to take a shot at answering a question about installation, or if that's
I can answer that one, Nick.
okay.
So yeah, so the XY stage, as far as installing it, it's really just a few bolts to secure it to the base of the system. The stage and the mounting, however, are quite heavy. However, you can leave it installed and run non-XY tests. So once you install on the system, any other manual test that you need to run, you can do so with the XY system in place up to 2 kilonewtons. And we have an adapter plate, which you can see on your screen here, which will actually provide your standard type O base adapter. It can also be made to provide your standard type D adapter, so that you don't need to necessarily remove the stage when it's not in use. If you do need to remove it, however, it is just about 5 bolts to unscrew and move the stage out of the way. I also want to address the, we have a question about can it be used with a full automation system? And this one cannot be. We don't have it set up where you can have a robot that can swap out test fixtures. However, we do have a range of full automation systems. My colleague, Matt Mayer, who is a product manager for Engineered Systems Group, recently, just a couple of weeks ago, provided a webinar around automation in the lab. So if you're interested, I suggest you can go to the webinar section on Instron's webpage, and you can look at that for reference. And then, of course, feel free to reach out to your local sales engineer with any questions. So I do see a couple of other questions that I think we'll need to take those offline in order to look up the information. So for those of you whose questions we haven't answered, we will certainly get back to you soon once we have a chance to pull together that information.
All right. All right. Thanks for answering those questions, and thanks everybody for sending those in. Apologies if we couldn't get you an immediate answer, but as I'm sure you understand, some of these are more like specifications, and it's good to have that exact information to supply to you. So before we wrap things up, I just want to mention that today's recording will be available on our YouTube channel in just a short while. Each of you will also be receiving an email with a link to the recording. I'm also going to get a copy of the slide deck from Theresa to include in that. And again, like Theresa mentioned, they are working on some videos, a more in-depth demonstration of the software. So as soon as that is available, I'll make sure that we share that with this group, just so you can have a chance to check that out. Next week, Jim Ritchie from our service organization will be joining me again, this time to discuss force calibrations, including ASTM E4 and ISO 7500, when they're used and some of the subtle differences. He'll also look beyond the standards and lead a virtual calibration to better explain what it is and why it matters. So you can find a link to sign up now on instron.com. With that said, I just want to thank Theresa for presenting today. Thanks to Charlie and Kyle for keeping an eye on questions. And also thanks to all of you for attending. We do really appreciate your time. I just want to say, stay healthy, everyone, and we hope to see you again next time.